everyone, my name is Julie Gomez and I will be presenting my findings in a Friedel-Crafts alkylation with p-xylene. Friedel-Crafts alkylations are substitute reactions involving aromatic rings that allow the introduction of an alkyl group to the product. In this specific experiment, p-xylene was alkylated using N-propyl chloride and aluminum chloride to form two major products. The objective of the experiment was to alkylate the p-xylene and to determine the amount of product that each product produced. In the experiment, we used two analytic techniques, gas chromatography, which is a separation technique to determine the number of products, and then mass spectroscopy to identify each of the products. The results showed that 1,4-dimethyl-2-propylbenzene was the major product with a 12% composition of the total product, and that the minor product was 2-isopropyl-1,4-dimethylbenzene, which had a 8.3% composition of the total product. Using the gas chromatography, we determined that there were three main peaks. One was the p-xylene and the other were the two major products. We also determined from the MZ values and their intensities, we determined the different fragmentations, which allowed us to identify the exact composition of each product. As previously mentioned, Friedel-Crafts alkylation are electrophilic aromatic substitutions. So we first go ahead and synthesize the electrophile using a halide, and in this case we used N-propyl chloride and aluminum chloride. The aluminum chloride goes and takes the chlorine and leaves us with a carbocation. The carbocation goes and reacts with the p-xylene, and then we have the formation of another carbocation, and the weak base takes one of the chlorines from the aluminum chloride, go ahead and take that hydrogen in order to form another pi bond to regenerate the aromaticity. Because the carbocation originally occurs on a primary carbon, a hydrate shift can occur to help stabilize that product, and this occurs because a carbocation on a secondary carbon is more stable than a primary carbon, and so this results in us having the 2-isopropyl-1,4-dimethylbenzene product. And so we have two products. We have the 1,4-dimethyl-2-propylbenzene and the 2-isopropyl-1,4-dimethylbenzene product. We go ahead and we use gas chromatography, which is a separation technique. The gas go ahead and flows through a column, and it records the retention time. The retention time depends on the boiling points. So higher retention times usually means that the product had a higher boiling point. We also have peaks in the gas chromatography, and the peaks determine the number of products. So in this experiment, we had two major peaks, therefore we had two major products. The area underneath each peak allows us to determine which product was produced more. Therefore, we can determine which was the major and which was the minor product. In this example, peak B had a smaller area than peak C, and therefore peak C was the major product and peak B was the minor product. The mass spectroscopy was this analytic technique allowed us to identify what peak B and peak C were. Using the MZ values and relative intensities, we were able to identify different fragmentations in order to obtain the exact molecular formula. Therefore, we could conclude, that peak B was 2-isopropyl-1,4-dimethylbenzene and peak C was 1,4-dimethyl-2-propylbenzene. For this experiment, in the experimental, we used 0.37 milliliters of dry p-xylene, and it was transferred into a conical vial, which was fitted with a stern vein, a cleansing adapter, along with a drawing tube containing calcium chloride, and sealed with a septum cap. This setup can be observed here in the image below. The 0.022 grams of aluminum chloride was then added, and then 0.112 milliliters of N-propyl chloride was added dropwise using a microneedle. It was then heated in a 50 degrees Celsius water bath for 1 hour, and then after it was removed from heat, 0.3 milliliters of water was added in slowly, and then the solution was washed with 5% sodium bicarbonate and then washed once again with water. This solution was then diluted in dichloromethane and then dried over sodium sulfate. In order to obtain the gas chromatography and the mass spectrometry, we took gas 1 centimeter above from the product, the liquid, and injected that gas into a GCMS analyzer. And then from that, we obtained the area, and from the gas chromatography, we obtained the area and retention times. From the area under the peak, we were able to obtain the percent mixture of each peak or each product. And then from the mass spectrometry, we obtained the MZ and relative frequencies, which allowed us to calculate or to figure out the fragmentations. In our results section right here, we have figures 1 and figures 4. We have the literature versus the experimental values. Figure 1 and figure 4 are the literature comparison and the experimental comparison of the gas chromatography of the alkylation of p-xylene. So we can observe that we have 3 major peaks, peak A being the p-xylene, peak B being the 2-isopropyl 1,4-dimethyl, and peak C being the 1,4-2-propyl methyl, 1,4-dimethyl 2-propylbenzene. We can observe that peak B has a smaller retention time than peak C in both. And we can also observe that peak C has a relatively higher area under the peak. If we move here to table 1, we can see that the peak B has a retention time, well, we can start off with peak A, actually, the p-xylene. Peak A has a retention time of 0.60 minutes, and which is very close to the literature retention time of 0.76 minutes, and a composition of 79.1, which is also close to the literature composition of 82%. Peak B, which was the 2-isopropyl 1,4-dimethylbenzene, has a retention time of 1.16 minutes, and which is very close to the literature value of 1.91 minutes. The composition percent was 8.35%, which is very close to literature composition of 7.9%. And peak C had the highest retention time of 1.30 minutes and an even higher retention time of the literature value of 2.13 minutes. It had a composition of 12.5%, which was higher than the literature comparison of 9.8%. Therefore, from the gas chromatography, we could conclude that peak B was the minor product, and it also had, because it had a lower percent composition than peak C, which had a higher percent composition of 12.5, both in the literature and in the experimental values. Then we can go ahead and see, The figures 2 and figure 5 are both the mass spectrometry of 2-isopropyl 1,4-dimethylbenzene, or peak B. And we can see that we have here on table 2, we have an experimental MZ of 105.0, which is very close to the literature MZ value of 105.1. And then we also have a experimental relative intensity of 32, which is close to the literature relative intensity of 28. And this fragmentation occurs when the isopropyl group is removed and it contains the negative charge. We then have the base peak of which has a MZ value of 148.0 and which is close to the literature value of 148.2. The experimental relative intensity of 28, which is close to the relative intensity of 26, and this occurs when there's no fragmentations. Then we have MZ value of 133.0, which is really close to the literature value of 133.1. And then this occurs when we have a methyl. The methyl carries the negative charge, and the relative intensity is 106, which is exactly the same as the literature value of 106. Then we have the experimental MZ value, which is 91.1, and it's very close to the literature value MZ value of 91.1, 91.10. And then the relative intensities are the same for this fragmentation. Both have a relative intensity of 22, and this occurs when the only the benzene ring is the benzene and the the benzene and the methyl group is counted for. And then in figures 3 and figure 6, we have the mass spectroscopy of peak C, which was 1,4-dimethyl-2-propylbenzene. In this peak, we notice that we don't have the 105 P fragmentation. We don't have the MZ value because this fragmentation occurs with the isopropyl, and we don't have that value because there was no methyl shift in this product. But we also have a different fragmentation. We have a fragmentation of 119, and this is because we have the removal of the ethyl group instead of the the propyl group instead of the isopropyl group, just a regular propyl, not isopropyl. And we have a comparison of 119.0 and 119.1, and we have a relative intensity of 104, which is really close to the 102 value of the literature. And then we have the base peak, which is 148.0 when there's no fragmentations, which is really close to the literature value of 148.2. And it also has a relative intensity of 22, which is close to the relative literature value of 28. And then we have the base peak at 91.0, which is just the ring and the methyl group, and that has the MZ value close to the literature value, the difference being 0.1. And then the relative intensities are also very similar, the experimental value being 22 and the literature value being 28. And then from this, we could conclude that there's two major products, peak B and peak C. There's two major products, peak B and peak C, but from those two products, peak C was the major product because from the gas chromatography, we had a higher air percent composition, and then we obtained that peak C, we identified it as 1,4-dimethyl-2-propylbenzene because according to the mass spectrometry of that peak, there is no isopropyl fragmentation as appears in peak B. So therefore we can conclude that peak B was 2-isopropyl 1,4-dimethylbenzene and peak C was 1,4-dimethyl-2-propylbenzene, and that peak C was the major product and peak B was the minor product. And overall the experiment was very successful. Both we were able to alkylate through the Friedel-Crafts reaction to produce the two major products. The major product being 1,4-dimethyl-2-propylbenzene and the minor product being 2-isopropyl 1,4-dimethylbenzene. The GC was used to determine the number of products and which was the major and minor product by comparing the retention times and relative percent of the mixture, which was calculated from the area under each peak. And then the mass spectrometry was used to identify the exact molecular formula of each product by using the MZ values and relative intensities in order to establish the different fragmentations of each product. And therefore we were able to conclude that peak B was the minor product, which was 2-isopropyl 1,4-dimethylbenzene. Peak C was the major product because it had higher composition, and that product was 1,4-dimethyl-2-propylbenzene. And the experiment was very successful because the literature values were very, very close or exactly the same to the experimental values, and therefore we can conclude that the success of the experiment was very high. Thank you everyone for your time. Hope you have a wonderful evening.